Ever wondered how files are shared over a network? Delve into the world of Network File System, or NFS, a protocol that paints a clear picture of this process. Developed by Sun Microsystems, now a part of Oracle, NFS is the key to file sharing and data access among different devices and operating systems within a network. It's a protocol that thrives in a client-server environment, where one or more clients can interact with and access files and directories stored on a remote server. Imagine being able to request files or data from a server that's not even in your immediate vicinity and interacting with those files as if they were stored right on your local hard drive. That's the magic of NFS. So, in simple terms, NFS is a tool that allows different devices to share and access files over a network. Now that you know what NFS is, let's dive deeper into how it works. At the heart of NFS lies the client-server architecture. The client, which could be your computer or device, sends out requests for files or data. The server, on the other hand, is the system that stores and shares these files. It's like a librarian, storing and providing books when requested. Here's where it gets interesting. To access files on an NFS server, the client performs a process called mounting. Imagine you have a bookshelf at your house and suddenly you're able to access a whole library's worth of books from that single shelf. That's what mounting is like. It makes the remote file system appear as if it were a local one, with all the remote files and directories accessible from your very own system. Once the client mounts the remote file system, it can interact with the files just as if they were local. Reading, writing, creating, and deleting files on the remote server becomes as easy as working with files on your own computer. You edit a document on your system, and the changes are reflected on the server, and vice versa. It's as if you're working with a mirror image of your files stored somewhere else. This seamless interaction is enabled by the communication between the client and server, facilitated by the Remote Procedure Call, or RPC protocol. This protocol operates over two others: the Transmission Control Protocol, or TCP, and the User Datagram Protocol, or UDP. Think of these protocols as the language that the client and server use to communicate. They ensure that your requests for files are sent and received accurately and the right data is delivered to you. But it's not just about accessing files. NFS also handles file locking, which ensures that when one person is editing a file, others can't overwrite it. It's like having an automatic reservation system in place. If you're working on a file, NFS makes sure your changes are saved before anyone else can modify it. Moreover, NFS employs a stateless protocol, which means the server does not need to keep track of client state information. This makes NFS more robust and simplifies recovery when a client or server fails. It's like having a self-cleaning system that doesn't hold unnecessary information, making it more efficient and reliable. And that's the magic of NFS, creating a bridge between your system and a remote server, making file sharing as easy as if the files were right there on your computer. It's a blend of clever protocols and processes, all working together to create a seamless file sharing experience. That's how NFS enables seamless file sharing, as if the remote files were part of your local system. But how does NFS communicate between the client and server, you might ask? Well, it's all about the protocol. NFS uses the Remote Procedure Call, or RPC protocol, which allows a computer program to execute a procedure on another computer across the network without needing to understand the network's details. This RPC protocol operates over two well-established internet protocols: Transmission Control Protocol, commonly known as TCP, and User Datagram Protocol, or UDP. TCP is used when data delivery is more important than speed, while UDP is used when speed is the priority, even if that means some data might be lost. These protocols enable NFS to communicate seamlessly between the client and the server, allowing for requests to be made and responses to be received, facilitating the smooth operation of the network file system. It's through this clever use of existing network protocols that NFS can function as effectively as it does. So that's the secret behind NFS's smooth communication. You're probably wondering where NFS is used in the real world. Let's take a closer look at some of its real-world applications. Firstly, we have file sharing. NFS is an excellent solution for sharing files and resources in networked environments. It's a staple in enterprise and academic settings where multiple users need to access and collaborate on shared data. Imagine a team working on a project. NFS allows the team members to work simultaneously on the same files, regardless of their location. Next, consider data backup and storage. NFS can centralize data storage on a designated server. This means that clients can back up their data to this central server, providing a consistent and redundant data safety net. It's like having a digital safety deposit box that multiple people can access and store their valuables in. Then there's virtualization. In virtualized environments, NFS is used to store and share virtual machine images and data among host servers. This provides a centralized storage solution for virtualized infrastructures. Think of it as a digital library where different servers can borrow and return books. Now let's talk about media streaming. NFS is employed in multimedia applications for streaming audio and video content. Media servers can store the content and clients, such as smart TVs, can access it over the network. So the next time you're streaming your favorite show, remember NFS might be working behind the scenes. In the realm of cloud computing, some service providers utilize NFS for network-attached storage solutions. Users can access and store their data on cloud-based NFS servers. It's like having a personal storage unit in the virtual cloud. Cross-platform file sharing is another practical application. NFS is supported on various operating systems, including Unix, Linux, macOS, and Windows, with the help of third-party software. This means that NFS can facilitate file sharing across different platforms. It's like having a universal translator for files and systems. Last but not least, NFS plays a crucial role in high-performance computing. It's used in clusters to provide a shared file system that enables parallel processing and data access for scientific and research applications. Imagine a supercomputer processing complex computations. NFS helps ensure that the system can access and process data efficiently. As you can see, NFS has a wide range of applications in our digital world. From facilitating collaboration and data backup to streaming your favorite shows and powering high-performance computing, NFS is a fundamental part of our networked world. It's the unsung hero, quietly ensuring that data is accessible when and where it's needed. So, what have we learned today? Well, we've delved into the world of Network File System, or NFS, a protocol developed by Sun Microsystems for file sharing and data access among different devices and operating systems in a network. We've understood that NFS operates on a client-server model, where the client requests files or data, and the server stores and shares those files. We've also learned about the concept of mounting in NFS. This is when a client accesses files on an NFS server by mounting the remote file system as though it were local. This means that remote files and directories appear to the client as if they're part of the local file system. Furthermore, we've explored the fact that once mounted, clients can read, write, create, and delete files on the remote server as if they were local files. Any changes made on the client side are reflected on the server and vice versa. And all this is made possible through the Remote Procedure Call Protocol over Transmission Control Protocol, or User Datagram Protocol, used by NFS for communication between the client and server. But perhaps most excitingly, we've looked at the real-world applications of NFS. It's not just a theoretical concept but a practical tool used in numerous contexts. NFS is commonly used for sharing files and resources in a networked environment like enterprise and academic settings. It's employed to centralize data storage on a dedicated server for backup purposes. In virtualized environments, NFS is used to store and share virtual machine images and data among multiple host servers. It's even used in multimedia applications for streaming audio and video content. And some cloud service providers use NFS for network-attached storage solutions. Plus, NFS allows for cross-platform file sharing supporting various operating systems. And let's not forget its use in high-performance computing clusters for scientific and research applications. In conclusion, NFS is an incredibly versatile protocol, enabling efficient, seamless, and cross-platform file sharing and access across networks. With NFS, sharing and accessing files over a network has never been easier.